Hello everyone! In this video, we will demonstrate service order management, and we'll start by visualizing the approach to organizing the product catalog. The product catalog consists of three main elements: offers, services, and resources. The combination of product offers defines the product offering for a specific client or subscriber. Typically, three categories of offers are used, namely Grace Activation, a basic offer that provides a basic configuration of services. The next one is the Override offer, which defines specific conditions for a particular period for a specific subscriber. And the Add-on offer, which can expand product conditions. Going deeper to the service catalog level, we see that the basic offer is decomposed into two types of services: consumption services and services of accesses, which provide direct management on the online charging level. It can be diameter, camel, radius, or similar protocols. And access services allow us to organize flexible management of the availability of these services. In fact, this is a binding to the entity of various features, which allows you to turn on and off a particular service during the life cycle of a subscriber and a service. Override offers include additional services and subscriptions to ensure recurring charging. They are usually in the form of a fixed subscription fee or an optional additional fee when using services in excess of the volumes included in the basic subscription fee. At the resource level, the basic structure of a product offer is based on logical resources that are associated with physical resources. With cellular communications, this is an MSISDN, which can have one or more SIM cards and can optionally have a terminal for IoT services. At the same time, it is also associated with product catalog entities, such as a tariff plan, a set of offers and subscriptions made from these offers. Let's move on to a demonstration. The screen shows the product catalog of the WideCoup BSS system. As an example, FTTB television services with certain codifications are taken. The catalog structure involves the identification and categorization of services, charge traffic services, and management services. Management services can have additional scenarios that can be activated when connecting or disconnecting services, or when their status changes, which makes it possible to organize flexible provisioning based on dependencies between services. Some services may also contain information related to the generic user profile, thus providing an additional level of flexible customization of the attributes of a particular service for management on an external device or network element. Here, services can be presented as SMS, voice, data transfer in roaming, without roaming, or for free. They can have different units of measurement and default quotas for integration with online charging. Services are combined into offers. Using the example of OTT services, we can look at the offer structure. This offer contains 4 services, which specify the tariffs that are applied when connecting or switching to this offer, supporting 2 pricing schemes: for greenfield connections and for the transition of existing subscribers to this tariff offer. This package also has a connection policy that is automatically applied to subscriber services when connecting and activating this offer. The structure of a product offer and its access policy can include an unlimited number of flexibly configured commands that can include a variety of formats for interacting with network elements. All commands are parameterized at the level of absolute attributes and custom formulas that can be used to dynamically fill identifiers associated with a specific subscriber. In terms of orientation to network elements, commands can be intended for both data transmission and television services, as well as for non-telco services and external workforce systems that activate or deactivate services based on a work order. The number of connected policies is unlimited, and each specific policy contains a set of commands that include a set of specific vendor attributes. In this case, these can be links to a service catalog and status. We see that the FTTB command, when implemented on the ISKRATEL network element, uses the activation of services with the classification 5050 and 5051, translating these statuses into identifiers 4, 8, and 9, thus activating the Gigabit Internet Access Service. In the command structure, we see that it identifies a specific task for a specific billing account. We have the identification of the command code tied to the equipment or the ISKRATEL network elements. Next comes the customization of the vendor ID command. We also specify the date and subscriber indicator as required by the ISKRATEL equipment and transmit the command, indicating which service profile should be enabled for this subscriber on the equipment. All this customization is used for flexible service management and connection without being tied to the actual representation of the command on the network element. Next, let's move on to a demonstration of service order management on the Enterprise Integration Platform MEF.DEV, which is used for the orchestration and management of telecom operator processes. We will start with service activation using an existing service order, which we will call from the WideCoup BSS system. This workflow is built using the BPMN 2.0 standard and allows us to visually display the activation process, which begins with a start element and ends with two possible final states. This is either an error or a successfully activated order. Here we see configuration preparation blocks, error handling blocks, including specific and general errors, and response generation blocks. This BPMN scenario can be compiled for execution on a network element. For testing, we can use two modes, namely debug and execute. And by passing the data model to the input, we will see how this scenario is executed. This workflow can also be published both to the workflow scenario library and as a separate version of the execution package, which can be delivered to a specific environment using the CI/CD process, or continuous integration, continuous deployment. We can access our workflow using the post command. Here you can see that we are accessing the platform, namely the import, personal library, and our name. Next, we specify to run the flow without debug, without asynchronous mode, and without waiting for incoming events. To execute the workflow, we use the input data model. The scenario is defined directly by the workflow developer. In this example, we use the TMF 640 service activation and configuration data model. We have already prepared a product offer, and all we have to do is activate it on the SIM card. To monitor the results, we will use the WideCoup BSS system, in particular the subscriber card for the number ending in 6368. At the moment, the subscriber card shows that the number is not activated and that it has a connected product offer with the M2M Advanced Tariff Plan, which has been valid on this number since April 1st, but does not yet have a SIM card and is not activated. According to the previously demonstrated configuration of the product catalog, we see that this product catalog has been connected, but not yet activated on this number. The access services, subscription fee, SMS, voice, and 3 over-limit services. We return to Postman and check that we have specified the correct values for activation. We see that this is the number we need, ending in 6368. We will activate it from April 1st, which we will do now by sending the post command. Activation was successful. In this case, we pre-configured two services, namely, services with codification 9215 and 9201, and put them in the financial block, making them unavailable for use by default. Let's get back to the interface, refresh the screen, and see that all services have been successfully activated, except for services 9215 and 9201, which should be in the financial block state. Returning to the card, we see that this number was successfully activated from a SIM card with the following ICC, and that the uni-type number is in the active status. This SIM card was activated on the HLR device via an external provisioning system. Now, we will demonstrate how we get information about the service. Using the standard GET method, which was received during activation, we get all the necessary information related to this service. This is a set of features showing which client it belongs to, that the service has been launched, and is now available for use. Among other characteristics, there are MSI, SDN, mobile, and other specifications that we have transferred for activation. And this SIM card is already in active status. Now, let's see how we can manage services through the same flow. Let's activate the two remaining services. Send the command. To check if everything went well, let's get back to the card and see that both services have been enabled. In order to demonstrate the flexibility of management from the self-service cabinet, we can transfer these services back to the unavailable state. Send the command again, refresh the screen and see that the two services we need are paused. We can also manage this process from the system available to billing administrators by going into the service editing mode and transferring them to the state we need. This block demonstrates how we can atomically influence a specific service of a specific subscriber, activating it and configuring it after activation. Let's look at a more complex example of a workflow. To do this, we'll download a scenario that creates an account and connects its product flow. This scenario was developed specifically for demonstration purposes. This workflow performs various actions, logs the results, calls get post and put commands, and so on. We can execute it to create a new product offer. We don't have an offer with a number ending in 6369 here yet, so let's create it. First, we'll compile and execute the workflow. It has some input data model and a phone number, and we want to create a product offer for it. To do this, we start the workflow and wait for it to execute. Here we show that the offer is executed directly from the BPM end designer, which is similar to invoking from Postman from an external system. As additional triggers, we can use not only manual but also scheduled execution, events from Kafka queues, or other triggers to run a particular scenario when managing the required input data. This workflow creates a billing account with a specific number of a specific type and in a specific state. It fills in the entire accounting model, generates a product offer, prepares it for subsequent activation, and we stop it to activate it manually, as I showed earlier. We see that the execution was successful. We receive an HTTP response indicating that the required set of features was created, the service has not yet been launched, and is not available for use on a specific client from a specific date. At the same time, the service with the specified identifier previously prepared for activation on this number was launched. If we search by number, we will see that it was prepared for activation on the specified personal account. Going to the subscriber card, we see a product offer ready for activation on a test corporate account. And we also wanted to demonstrate the flexibility of changing the workflow to connect additional actions. For example, using a webhook. To do this, we will open another workflow from the local library. I wanted to note that all workflows are logically combined into libraries that can be connected to Git for automatic code versioning. For demonstration, we will use the online webhook service. To do this, we copy the webhook link and change our flow, adding an additional stage after activation. We will use the HTTP GET function. Since this works without authorization, all that remains is to send the webhook and see how it is displayed here. Let's save and compile our flow, and now we can execute it. Just wait for the execution success status and check. As we can see, the webhook was executed successfully from our external IP. Thank you for your attention.